right? So next, let's take a look at how do we figure out the ratios, right, in any of the quadrants. Because when you're looking at radians, for example, right, so we can have 0 to pi over 2 here, and then you keep going, you'll hit 2 pi. If you keep going, there'll be like 3 pi, 4 pi, or if you're going the other direction, you will have negative angles. So we do know that, once we know the ratios in one quadrant, we're able to figure out all these other ones. We just have to choose the correct sign. But let's look at how, given any angle, we can figure out the trig ratios if you knew the corresponding trig ratio in the first quadrant. So what is the idea? That we know the ratio of the angles in the first quadrant, that is 0 to 90 degrees or 0 to pi over 2 radians. And using that, we want to be able to figure out the trig ratios of any angle. That's the idea. So let's go back to what we learned previously about this idea of a reference angle. So let's say this is theta. So this is the angle in standard position. The vertex is at the origin. Initial side is the positive x-axis, and the terminal side is wherever it is. So theta is the angle, and I want to find out, let's say, sine theta. I want to find out sine theta, but theta is obtuse, right? It's bigger than pi over 2 here. And I only have the knowledge of the angles smaller than pi over 2. So in this case, what's the reference angle? This is the reference angle. So let's say, let me call this as alpha. So here, this is the reference angle. And reference angle you take as positive. So whatever that alpha is, you take it as positive only. Now we know that is less than 90 degrees. It's acute angle, right? It's less than pi over 2. That means if I just looked at alpha by itself, it is in the first quadrant. Meaning if I draw it like this, and that's alpha. So that would be in the first quadrant, right? So I want to write down sine theta in terms of the reference angle. So if you look at it, sine theta is this. If you look, remember the unit circle, this would be sine theta, right? This length. Even in this triangle, it is the same. If you just look at this right angle triangle, that is still the sine theta, but this is also sine alpha. So in this case, sine theta equals sine alpha. Quadrant 2, right? If you're in quadrant 2, then sine theta is same as sine alpha, where alpha is the reference angle for theta. And what is cosine theta here? This would be cosine alpha, right? But we are here in the second quadrant. So what is this point on the x-axis? This triangle is same as that triangle, just it's flipped, right? So this is negative cosine alpha, right? So this means cosine theta equals negative cosine alpha. And tan theta is sine theta over cosine theta, right? Which is, so this is negative tan alpha, because sine alpha over cosine alpha is tan alpha. So here you see how we found for any given angle theta, we found its ratios using the ratios of the reference angle. We first have to find the reference angle correctly, and then we are able to find it. So let's look at some examples. So it will be here somewhere, right? So what is the reference angle here? 30 degrees. Correct. So we know that this has to be sine 30, but we don't know plus or minus. That we will see. So what do you think? So if we do this, right? Is the sign going to be positive here or negative? Negative. Because for the acute angle, sine, cosine, tan will be positive. So we have to put a negative here to get it to make it negative. And cosine 210 degrees will be cosine 30, but I have to see positive or negative. X coordinate is negative, so negative. And tan 210 degrees is tan 30 degrees, but negative, negative cancels, so positive. Right? Do we know what is sine 30 degrees? Sine 30 degrees half, so this is negative 1 half. Yes, so this is negative root 3 over 2, and this is 1 over root 3. And what is cosecant 210 degrees? So cosecant is 1 over, so 1 over sine 210 degrees, which we know is negative 1 half. So 1 over negative 1 half, which is negative. And secant 210 degrees is 1 over cosine 210, which is 1 over negative root 3 over 2, which is negative 2 over root 3. And cotangent 210 degrees is 1 over tan 210 degrees, which is 1 over root 3, which is root 3. Okay, so in this manner, we can find the trig ratios for any angle by using its reference angle. Okay, because sometimes the angles could be much bigger. So let's say if my theta is, let's say 700 degrees, right? Then how do I find the reference angle? So remember that you can add or subtract a full circle any number of times and you will end up at the same place. What you get is a coterminal angle, which means suppose you're here, right? This is my original angle, theta. Not this theta, but let's say something else, say beta. If I go around one more time, I still end up at the same spot, right? But I have gone around 360 degrees more. Or if I go back one whole circle, I have gone 360 degrees back or negative. That means I can add or subtract 360 degrees any number of times and I get a coterminal angle, meaning I end up at the same spot. In terms of radians, I can add or subtract 2 pi's any number of time and I will end up at the same spot. So first I want to get to something smaller than 360 degrees positive, and then I can see what is the ref angle. So how can I get here less than 360? I can subtract 360 here, right? What do I get? 340 degrees. So now this is 360, so 340 is somewhere here. And I need to know what is this angle, right? So since I need to know the acute angle with the x-axis, it will always be either here, right? Or here, or this, or that. So either we are talking about 0 plus something, right? Or 360 minus this to get that. Or I am doing here, this is 180 minus that. Or I am doing whatever this is minus 180. Or I can do 180 minus here also. I just have to take the positive value, right? So here, now I got 340. So since I have got 340 here, I can do say 340 minus 360 is negative 20, but I need to take the positive value, so it's 20 degrees. Right, so you see this is bigger than 2 pi, right? What is this? 2 and 1/6 pi, right? So that means it's more than 2 pi, I can subtract 2 pi. What is left? 1/6 of pi, so pi over 6. This is the reference angle. Because pi over 6 is less than pi over 2, it is in the first quadrant. It's positive, that is the reference. If I have theta as negative 19 pi over 6. So I can write this as negative 19 pi over 6 is 3. 19 over 6 is 3 and 1/6 pi, correct? So I can add, this time it is negative, so I can add 2 pi, it will still be negative. I can add 4 pi, then it will be positive. So I can add 4 pi. It added 2 pi 2 times. So what is that? 4 minus 3 and 1/6 is 5/6. 5/6 of a pi. Now 5/6 of a pi is close to pi, correct? 5/6 of a pi. So this is pi. 5/6 of a pi is somewhere here. So then I can subtract it from pi. So pi minus 5/6 of this is pi, right? And this is 5/6 of a pi. So their difference is this. Is pi over 6. So that is the reference angle. If it came negative, then I would just make it positive for reference angle.